An AI-powered legal assistant confidently cites a court case that doesn't exist in a multi-million-dollar lawsuit, instantly creating grounds for a mistrial. A financial chatbot built to serve several high-value clients invents a non-existing investment product, triggering a regulatory chaos and destroying the trust of that financial organization. This is not a hypothetical scenario. These are real failures that are happening right now caused by single dangerous problem in AI, hallucination. This is when a large language model confidently produces an information that is completely made up. And it's the number one barrier to deploying AI in high-stake, mission-critical environment. Now, for years, developers have tried to patching this with prompts and quick fixes, and that's not enough. But what if there was a framework that companies are using right now to systematically detect, eliminate hallucinations at its source, which is a proven method that can cut the hallucination time sometimes by 70 to 80%, and in some specific cases, even up to 90%. In this video, I am going to show you exactly how to do it using a powerful open source tool called TruLens. First, let's be clear about what a hallucination actually is. It's not a minor factual slip or something that's happening that you can ignore. It's when a model generates information that is false, unsupported, or irrelevant, yet it presents with compelling case and extreme confidence. Think of that talking to a very convincing liar who doesn't know that they're lying. They're not lying to deceive you. They're predicting what sounds right. In their mind, they're absolutely correct. Here's an example. A customer support bot confidently describes a refund policy that doesn't even exist. Or an AI research assistant remembers a product that the company has never produced. This destroys the trust in the organization, and for organization, trust is everything. Now, until recently, it was nearly impossible to measure the hallucinations reliably. Trying to fix hallucination without measurement is kind of putting your hands and trying to catch smoke. Now, to fix hallucination, you have to understand the root cause of hallucination. LLMs, like GPTs, they're not encyclopedias. Basically, what they do is they're just next word prediction machine. They're trained on massive internet data sets. When you ask a question to an LLM, they're not necessarily looking for information like a search engine. They're trying to generate the next word in the sequence of the words. Prediction is not going to be truth. It is just a core mechanism of how LLM works. And that's exactly why hallucination happens. Now, to ground the model in real and up-to-date information, the developers have introduced retrieval augmented generation, which is the RAG. Now, before answering the model exactly retrieves the information and knowledge document from your knowledge base. Now, RAG is a huge leap forward, but it does introduces brand new failure points, and let's talk about that as well. So RAG follows a simple rule: garbage in, garbage out. If the retrieval pulls irrelevant or outdated information, then the LLM will happily generate confident in the content that is not correct because it's been provided that bad context. Here's an example. You're asked about pricing details. The retrieval is going to pull details from 2019 policy documents, and the model is going to confidently answer the question with outdated rule. This is still hallucination, it's just a different flavor. Now, most teams, they try to fix with wipe checks. Like, for example, they're manually testing out a handful of prompts, but you're not going to build an enterprise-grade AI solution just with gut feeling. You need a systematic, measurable way to evaluate every step of this RAG pipeline that brings us to the new platform that I'm talking about is TruLens. Now, the real magic is not like a bunch of prompts or secret prompts or line of code. It's moving away from guesswork to evaluation-driven development. And TruLens is an open source framework designed to evaluate and monitor LLM apps with high precision. TruLens has popularized a now widely used approach called RAG triad, which basically breaks down evaluation into three measurable pillars. First is context relevance. Did we retrieve the right information? If the user is asking about pricing and the retriever turns an HR onboarding document, the context relevance score drops. This flags a retrieval problem immediately, even before LLM generates a response. Second is groundedness. It is the final answer supported by the context. TruLens breaks the answer into statements and checks whether each verified information is retrieved from the document. Here's an example. The context contained no mention of premium tier, but the answer confidently is recommending a premium tier. So the groundedness score drops, and this is direct hallucination detection. Number 3 is answer relevance. Does the answer actually addresses the question being asked? So even with perfect context and grounding, the model still dodges the question. Here's an example. If the user asks, what is the length of the product warranty? The model gives product summary instead of giving the details of the warranty. The answer relevance is set to low. With this triad approach, you're no longer guessing, you are engineering with hard metrics. Here's how TruLens works in practice. Now, TruLens is a lightweight Python library. You can integrate into your existing RAG application, whether you're using LangChain, Llama Index, or your own custom stack. With just few lines of instrumentation code, then you define the feedback functions of the 3 triad metrics that we talked about. These evaluators are often powered by modern LLM themselves, acting as an impartial judge. In other words, you're using one AI to evaluate the other AI, creating a scalable, automated quality control that is far more reliable than the manual human review. Run a batch of test queries and TruLens logs everything. Retrieve documents, model responses, evaluation score, and it visualizes into a neat little dashboard. So you're going to be able to instantly see where the retrieval is failing, where the ground breaks, where the answers drift off from the core topic. The black box, which we think all AI is finally open. Now let's look at a specific case study with measurable results. Now, by adopting this evaluation-driven approach, developers have been able to dramatically improve the accuracy of the model output, with some studies showing that the RAG-based system can cut down hallucination by up to 70%. Example 1, financial reporting summaries. So retrieval is going to check to ensure the right tables of this financial information is pulled into the model. Groundedness is going to prevent invented numbers, and answer relevance is going to ensure these summaries are actually addressing the analyst's question. Another example for a customer support chatbot. Outdated articles are identified through low context relevance. False information claims flagged by groundedness, and the response drift are caught by answer relevance. Every improvement cycle, it follows a pattern, which is retrieve, evaluate, and optimize. And this reduces the hallucinations further. Now, here's where it gets even more powerful. TruLens integrates with open telemetry, letting you monitor your app in production. So that means you can now track the hallucination rates that are happening over time. You can also detect the drifts as the user queries are going to evolve. You can monitor the cost and latency. You can catch the retrieval failures almost immediately. This RAG triad gives you a grounded data, and fine-tuning helps you adapt the model even further. Finally, the evaluation gives you a continuous trust in the model. This is the completes the RAG triad loop, and it turns AI development into a disciplined engineering versus practical guesswork. That era of tweaking the prompt with trial and error is over. The TruLens RAG triad gives you a clear blueprint to contextual engineering and grounding and relevance, so you can dramatically reduce the hallucination and build a system that your users are going to trust. I've linked the documentation and the GitHub repo below so you can start using TruLens yourself. Make sure you subscribe to the channel, and if you want to understand why massive context windows don't solve the hallucination and why you still need a RAG triad and evaluation methodology, watch this next video called the 1 million token lie, why big LLM context windows fails.